Lesson 53 has two different parts. The first part is on the power rule for exponents, and then the second part is on conversions of volume. So in Lesson 53A, the power rule for exponents, let's just use an example to understand this. Let's say we had x squared times x squared times x squared. Well, we know that that's equal to x to the 6 because we can add those three exponents together. 2 plus 2 plus 2 is 6. Now, another way to do this, if we had this problem, it's the same thing. X squared, that quantity to the third power. Now, when we see that power on the outside of parentheses like that, that indicates to us that we need to multiply 3 times 2. We wouldn't add those two things because it's different than what we have in that previous example. In the previous example, the powers all go right above the variable. In this case, there's a power above the variable, which is the 2, and then there's one outside the parentheses, and so that means we're multiplying x squared 3 times, or x to the 6th. 2 times 3 is 6. So both of those examples, you get the same result. Just one of them, the bottom one, we're saying multiply x squared 3 times in a row, and a simplified step of that is just doing the power rule for exponents. 2 times 3 is 6. So to write this in terms of any variable and any exponent, you would say x to the m times n, that equals x to the mn, like that. So let's use what we've learned about the power rule and apply that to some problems to simplify those. Look at practice problem A. Let's go ahead and simplify that, and when we get done, let's write all of the variables in the numerator. So just keep that in mind. It doesn't matter if they're positive or negative, we just want all the variables in the numerator. So we take that 4, and we start with that, and we'll do that 4 to the negative 4 power, because really it's 4 to the 1, right? So we do the 1 times negative 4 is 4 to the negative 4. And then we'll have x to the negative 8, because 2 times negative 4 is negative 8. Y to the negative 4, because y is really y to the 1. And then z to the negative 12 over m. Even though m's in the denominator, we still do m to the 1 to the negative 4, or times negative 4. So that would be m to the negative 4. We want to answer this, or put our answer with all the variables in the numerator. So let's rearrange some here. And we can move that 4 to the negative 4 down to the denominator. That would make it 4 to the positive 4, or 256. So we will have a denominator on this of 256. And then in the numerator, we'll have x to the negative 8, y to the negative 4, z to the negative 12, and m to the positive 4, because we have to move that up since we were saying we want to write all the variables in the numerator. So our first step through on a problem like this is to use our power rule to simplify the problem, and then whatever they ask you to do, like in this one, I asked y'all to put all the variables in the numerator. That would be your second step. Let's do another one. And so we have two factors here basically, and so what we want to do is use our power rule first to get rid of that exponent on the outside of the parentheses, and then we'll simplify as we need to. Everything's multiplication here. There are no plus or minus signs between parentheses, so we know that everything we'll be doing is multiplication. So we have a squared to the minus 2 power. That would be a to the negative 4. Then we have b to the negative 4 over x to the negative 6, m to the positive 4, because we have minus 2 times minus 2. And then we could just put a little time symbol here and say y cubed b to the 9 over x to the 12. Now let's go ahead and simplify this, and we'll end up with a to the negative 4, and then b to the 5th and then we'll also have y cubed. So that's our numerator. The denominator, we have x to the minus 6 times x to the 12. That'll be x to the positive 6 times m to the positive 4. Now let's write our answer with all variables in the numerator. And so that'll give us a to the negative 4, b to the 5th, y cubed, x to the negative 6, m to the negative 4. And so there's our problem there. Now remember, we could have written our answer with all the exponents positive, with all the exponents negative, all the variables in the numerator like they are, or all the variables in the denominator. There's 4 different ways to write the answer to these problems. I just told y'all to do it with all the variables in the numerator. And just whatever they ask you to do in the textbook with that problem, make sure you do it that way. It's not necessarily wrong if you do it that way, it's just that you didn't follow directions correctly. So the power rule, right here we're just trying to understand how to use the power rule, and it's just that anytime you have an exponent on the outside of parentheses by itself, that means you multiply that exponent by any exponents that go along with variables on the inside of the parentheses. Now part B of this lesson is on volume conversions, and here we'll be converting from one unit of volume to another. Now we've been doing conversions of length and of area, and let's just kind of review that real quick. Let's say we wanted to convert 6 feet to inches. Well, we would write down 6 feet, and then we would think of a unit multiplier that would convert feet to inches, and we know that there are 12 inches in a foot, so we would put times 12 inches over 1 foot. So that would convert us from 6 feet to inches. Now, what if we wanted to do 6 feet squared to inches squared? We'd have a squared term right there, and now we would need 2 of the same unit multiplier. 12 inches per foot times 12 inches per foot. Okay, so that would be a conversion of area. Now let's go one more step and think about volume. What if we wanted to convert 6 cubic feet to cubic inches? Well, we would need a third conversion factor similar to the first two, 12 inches over 1 foot. Now remember why we need that, because feet cubed, that's the same thing as saying feet times feet times feet. So we would need 3 factors of feet in order to convert from feet cubed to inches cubed. So let's go ahead and do some practice problems. Look at practice problem C. Convert 45 inches cubed to centimeters cubed. So let's go ahead and write down what's given. Remember, that's always what we do first on these unit multiplier problems. 45 inches cubed. And we want to convert that to centimeters cubed, so we think, what unit multiplier could I use to make that conversion? Well, hopefully you know that there's 2.54 centimeters in an inch. And so we would do that 3 times. 2.54 centimeters over 1 inch times 2.54 centimeters over 1 inch times another one, 2.54 centimeters over 1 inch. Okay, so we have inches times inches times inches, or inches cubed. So those inches cancel. And therefore, we're left with 45 times 2.54 3 times, or we could just simplify this and use an exponent, 2.54 cubed, and then our units are centimeter times centimeter times centimeter, or centimeter cubed. So that's our answer there. 45 times 2.54 centimeters cubed. Now, one thing you could do to simplify these problems so you don't have quite so much to write out is, let's just rewrite this one over here. You could say 45 inches cubed times 2.54 centimeters over 1 inch. And you could just put a cubed term right there to represent that you're multiplying that same conversion factor 3 times. And then you can just go ahead and cancel your inches and write your answer as 45 times 2.54 cubed, and then centimeters cubed, just like you did in your answer before. So instead of having to do the same conversion factor 3 times, just cube it. You could do that on area too. Instead of writing the same conversion factor twice, you could just square it at the top. If that confuses you though, go ahead and write it out, all 3 of them, just like I showed you in the first example there. Look at practice problem D. Convert 28 centimeters cubed to feet cubed. So we want to write down what's given first, just like we always do. 28 centimeters cubed. And now we need to convert that to cubic feet. So we just think, well, how would I get from centimeters to feet? Well, I could go centimeters to inches, then inches to feet. So I'll need 2 different unit multipliers here. But each of them have to be cubed or repeated 3 times. So we'd have a total of 6 unit multipliers to write out. So that would really be tedious to do that. So let's just go ahead and cube each unit multiplier. So we'll say 1 inch over 2.54 centimeters, and then we'll cube that whole unit multiplier to represent that we're multiplying that 3 times. And then we'll do the same with the next one. We're converting to feet, so we say 1 foot over 12 inches. Cube that. Now let's make sure our units canceled. Inches over inches, centimeters cubed over centimeters cubed, and then we'll simplify this down to 28 over 2.54 cubed. I'll put that in parentheses. 2.54 cubed, and then times 12 cubed. And the units are feet cubed. So there's our solution there. Remember, on these unit multiplier problems, we don't get an actual numerical answer. I mean, we could real easily, but that's not the purpose of the problem. The purpose is to see if you can convert using unit multipliers and get the appropriate unit and the numbers in the right places. Okay, well that's all for lesson 53.